Okay, can you open yesterday's lesson? We'll start with 1c. So you have y equals 2e 9x. So the rule here is you bring the 9 down, and that's it. So we're using the rule y equals ekx, dy dx equals ke kx. Okie dokie? Huh? 1b. Okay. 1b. Y equals 5 root x, which equals 5x power a half. So dy dx equals 5 over 2 x minus a half, which equals 5 over 2 root x.
Why didn't we do -1?
That's only for x, not for e.
So if there's an e, we can't.
Which one? 2f and 2g. 2f and 2g. Okay. Was g the one we were looking at yesterday? Yeah. Okay. And f. Okay, let's look at 2f and g on page 64 in a second. Did you watch the videos while you were absent?
Yeah.
But you
A
didn't
lot.
comment. No comments.
Oh, I liked.
Okay, I guess that's enough then. Right, page 64. Are we ready to look at this one? Yes? Okay, 64. So as 2f minus 7 sine 2x minus pi over 36. We're using radians. And can you see, I say x is between 0 and 2 pi. Yeah? Now, you'll need your calculator, but before we start, how many solutions? 4 solutions. So we'll say sine 2x minus pi over 36 will equal 3 over 7. Now, can somebody please give me, in radians, the sine inverse of 3 over 7? Ah, you're in degrees, aren't you? Yeah.
0.113.
One more decimal.
0.4429.
Thank you. Okay. Now, how do we get the second answer for sine? Yeah, question? Yeah.
Yeah, how do we get 0.4429?
Sine inverse 3 over 7.
Oh, sine. Okay.
How do we get the second answer for sine? Yeah, minus. But if we're using radians? No. Pi minus. Yeah. Remember we said 360 is 2 pi, so 180 is pi. So if we type in the calculator pi minus this number, what do we get?
2.6987.
Okay. Now how do we get the next two answers? Plus 360, or in this case, 2 pi. So if we add 2 pi to these two answers, what do we get? So maybe we can get this, please. 6.7261. 6, okay, and then the last one,
8.9819.
8.9819. Okay, so we have 2x minus pi over 36 equals a number, 4 possible numbers here. So what would then the x equal? X would equal that number, or sorry, I should already say that angle. I don't never use hashtag. I'll just write the word in angle. You can use whatever symbol you want. Angle. So therefore, the x will equal the angle plus pi over 36 divided by 2. So if we do that 4 times, let's see what our 4 answers are. So, what one is this? 2f, isn't it? So hopefully you should get 0.265, 1.393, 3.407, and 4.53. Now actually, I want to use 3 significant figures, so that would be 1.39 really, and then 3.41, and then 4.53. Okay, yeah. Now the last thing to do is make sure each answer is in the range. As a decimal, how big is 2 pi roughly? It's about 6.283. So is this within the range? Yep, 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 and yep. So we're done. Okay, as soon as you write that down, we'll look at the next one, which is 2g. Bit hard to see in the corner, is it?
Yes.
Okay. Do you all have that? Is that yes or no? Yeah. We'll look at the next one. Okay. Right. Okay, what do we have happening here? 7 tan 3x plus pi over 4 plus 2 equals 0. And this time x is between minus pi and pi. Okay. Tan 3x plus pi over 4 equals minus 2 over 7. So, can somebody please type in tan inverse minus 2 over 7 in radian mode, and let's see what we get.
Minus 0.278.
278. Okay. Now, how do you get the second answer for tan? I think you just add pi. So if we add 3.14 to this, what do we get? 2. What do we get? If we add pi to this?
2.863.
Okay, now, how many answers should we have in total? 6. So there's 1, 2. Okay, so we have to add 2 pi and 2 pi to each of these. So what are our next two, please? 0049, okay.
9.146.
146, okay. Next one down, 2 more.
4.288.
Okay, and the last one.
15.4297.
Okay, so here x will equal the angle minus pi over 4 over 3, yeah. So let's see what our 6 answers for x could be.
Teacher is 15.4297.
Oh, that's okay, because I'm going to round it in the final, so it's accurate enough at this step. What's the first one, please?
Negative 0.35.
Minus 0.3.
546.
Okay, so if we do 3 significant figures, it's that. Yeah, okay. Next one?
0.69.
690, is it? Yeah. So 690 like this? Oh, 692, sorry. Okay. Next one?
Yeah, I think it's 92 because it's 0.6966.
Oh, okay, 93. Thank you. Next one?
It's 1.74.
Okay. Next one?
2.78.
Thank you.
And then
Yeah. This one now.
Three point
3.83. Yeah.
Yeah.
And the last one now.
4.88.
Now, the final step is we need to fix any answers outside the range. And the range here is minus 3.14 roughly to 3.14. Okay? So, inside, outside. This one, inside, 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 outside, outside. What are we allowed to do to bring something within range? Plus or minus 2 pi or 360. So which is it going to be, plus or minus here? Minus, yeah. So can we minus 2 pi from each of these, and hopefully that will bring us within range now. So what do these become?
Minus 2.45.
Minus, the first one is,
Minus 2.45.
Yeah. and then the next one?
Minus 1.40.
Minus 1.4? Yeah, okay.
Okay.
So it looks like the x's could be minus 2.45, minus 1.40, minus 0.355, 0.693, 1.74, and 2.78. So that's okay, that's okay. We must have made some rounding error at some point here, perhaps it's 358. That looks okay. 1.737, yeah, that looks okay. 2.78, so really that should be 2.79. Okay, so I think perhaps I was a little bit too early in my rounding here. I think I rounded too early. I don't know, I'm sorry, I shouldn't have done 3 significant figures at this step. I should have only done that at the end. So this makes these two a little bit off, it would seem. But anyways, it looks like it's pretty much right.
Is it okay if we round in the tests or exams?
Yeah, I really shouldn't have done that. That would have been bad of me in the exam. Should leave it until the very end to round.
So,
Yeah.
how do you know that this one has like 6 answers?
Because of the 3x.
Oh, okay.
It's twice the number of the coefficient on the x. One sec there. Did that clear that up?
Yeah, I had similar answers, just the digits are a tiny bit different.
Okay. Okay. Yeah? question?
Yeah, so if we want to like bring that into the range, we have to always minus it by 2 pi.
Or add, whichever will help.
Minus or add 2 pi.
You got a question?
As a question for
Yeah. Yes, yes, yes.
So practical problems for which we're
Yeah, which one?
number
6. Ah, yes, 6. Page 62, 6 now.
Question
One sec, yeah.
Is this value of x is the x-intercept?
Say again, sorry?
Is this value of x is the same as x-intercept? Is it more of the
This value of x is the same as what?
x-intercept?
Oh, yes. You mean if you could graph this? I see. Yeah, they're the x-intercepts
Okay, so
for,
can I,
for, for this original tan graph.
okay, so can I first find the period of the tan, then find the x-intercepts without doing the equation?
Yeah, but I think that way would be a lot easier if this was a 0. If my question instead was, say, tan 3x plus pi over 4 equals 0, without this plus 2 over 7, then yes, I think I know what you're saying, that you could look and find these, is it?
Yeah.
Yeah, no, that's fine, but it's very hard to do that when you don't have,
I don't even have to graph it, just to find the values.
for the,
Just find the period,
yeah,
then add or subtract or multiply by a, b, c in the equation.
but are you looking at the roots?
Yeah, because always sine 0 over
Yeah.
cosine x. Sine will always be values like
But
0.
it's, I suppose you're not quite looking for when it's 0, you're looking for when it's minus 2 over 7, so really, you could think about it like this. You're looking for where it crosses this, the minus 2 over 7. Now, you could bring the minus 2 over 7 to the left and make the graph like this and find the roots.
Yeah.
But the problem is with the 2 over 7, it's kind of harder to find the period now, because it doesn't just depend on this.
I can find the period first, then leave 2.7 to the last step, then add it.
I don't think that would work. I'm not sure. I would have to see what you write down. I would be skeptical. But if you want to try it, I'll have a look at what you did. And if it doesn't work, I'll tell you which step the problem was. So you can give it a go, but I'd be a little bit cautious. Okay, what do we need to see next?
practical problem.
Oh, that's right, number 6, yeah. Al-Biruni, while staying at Nadana, estimated the radius of the Earth by first measuring the height of a nearby mountain. And he measured the height to be 321 metres. He then climbed this mountain and looked to the horizon, and that made an angle of 0.567 degrees with the horizontal, as shown in the picture below. What is the radius of the Earth? So, let's draw the picture again here. So what's happened is, he's climbed to the top of a mountain, and you know this distance here. Now obviously it's not the scale. You know this distance here is 321 meters, isn't it? 321. And then what he's done is he looks to the horizon. So what that means is you're looking to the point like here, where it's still a tangent. It's just about a tangent, your line of sight. So that means that there we know is 90. And what angle is the 0.567? Well, through his point of view, if he's standing on top of the mountain here, that's the angle measured downwards. So if you put like a little sort of cross here, in brown maybe, from where he's standing on top of the mountain, that's this angle here. Okay? So I'm a little bit tight for space. What I'll do is I'll just call this angle alpha and this height h, which I think is the letters I used here. Yeah. We know these two pieces of information. And we're looking for the radius here, or. Now, this length here is also or. If that's alpha, then how big is this? 90 minus alpha. And then how big is this? 90 minus 90 minus alpha. So it actually turns out that this will be the same as alpha. So if we look at this triangle, what do we need to use? Sine, cos, or tan if we're looking at this side and this side. You can say cos alpha equals or plus h over, no sorry, I wrote that backwards, didn't I? Cos alpha equals or over or plus h. That means or cos alpha plus h cos alpha equals or. That means h cos alpha equals or minus or cos alpha. That means h equals or minus or cos alpha over cos alpha. That means h equals or 1 minus cos alpha over cos alpha. So that is equal to 321 times 1 minus cos in degree mode 0.567 over cos 0.567. What do we get? Oh no, we know the Earth is more than this, don't we?
I still got 0 point.
What? Are you guys in radian modes on your calculator still?
No.
No, goodness, no. Yeah?
Isn't H 3.21?
321.
321.
Yeah. Mountains tend to be higher than 3 meters. So,
Did you put it in as R or
oh, rats, stop. I'm sorry. I see what I did. That was so stupid. I made the wrong subject, didn't I?
Yeah.
Yeah. What should I have done? I should have put the or on the, yeah. Disgraceful. Okay, so let's clean this up. H cos alpha equals or times 1 minus cos alpha. Oh, it's nearly the same thing. It's just I think the fraction's upside down. So or equals h cos alpha over 1 minus cos alpha. So it was upside down, wasn't it? Or equals 321 cos 0.567 over 1 minus cos 0.567. Alright, now what do we get? We get a decent number now. Big number, right? Yeah. What? No, it should be a big number.
6555358.593. Is
But
that right? It should be-
so that would be if you divide that by 1,000, you can make it kilometers. So what do you get?
Is that right? It should be
Yeah, no, that's right.
65. Okay.
What have you got?
6,555.
Yeah, which I rounded off in the book as 6,600.
Can be rounded off.
Yeah, the question actually says correct to 2 significant figures. Number 6 is a true story, by the way. I can't remember what year it was. Hmm? No, I mean it's this is a historical situation that happened. Yeah. Yeah.
So this at page 70, G, number one.
70.
Yesterday's one,
Yeah, which one?
G,
G. 2 tan x.
yeah.
Yes. Yes.
Same thing as before, question 3.
On which page?
Page 62.
Oh,
62, question 3. Okay, well I'll just do 70 first and then I'll do 62 next. So on page 70, what is it?
G.
G? So you have y equals 2 tan x. So according to the rule, this should be 2 times 1 over cos squared x. Because I think the rule I gave you was tan x, or maybe it even was tan kx.
Yeah.
In this case, the k is 1. It was k over cos squared kx, isn't it?
Two.
What's that? Problem? It's okay? Okie dokie, you got that? Yeah. Page 62 now, number 3. The Earth revolves around the Sun. It is known that the radius is about that many meters. So anyways, I'll draw the picture for the story here. What's happening is, there's the Earth at one time of the year. There's the Sun, and there's the Earth at the other time of the year. And A is 70 degrees and B is 80 degrees. So there's A, 70 degrees, and then B is 80 degrees. So that's a bigger angle. So it means whatever you're looking at is somewhere over here. And the question is, what's the distance from the Sun to the object you're looking at? So what info do we know? We know the radius of the orbit here, don't we? I'll just write or here and or here. And we know angle A, don't we? Oh, actually, I'll put it in the number. That's 70, and that's 80. So we could know this angle, couldn't we? That's 30. So I think it would be useful maybe to get this length first, and then from that, get this length next. So if I use the cosine rule, or the sine rule, yeah, I could say sine 30 over twice the radius, which we know, is equal to sine 80 over L. So L would equal 2 or sine 80 over sine 30, right? Yeah. So that's 2 times 15 times 10 to the 8 times sine 80 over sine 30. So we have our L now. Once we type that in, please, what do we get? I would imagine it is a big number. Oh, let's give it as a power or something. Can you convert on the calculator?
I don't know how to.
Oh.
Does anybody know how to convert underscore plus.
Why don't you take your answer and divide it by 10 power 8 and tell me what you get?
59 point.
Yep.
0.
Okay, so 59.1 then,
Okay.
times 10 power 8.
Okay.
Now, x, what rule would be best to give me x? Sine rule again? Yeah. You can say x over sine 70 isn't that right? Equals L over, oh, no, actually maybe not. I'm missing some angles, haven't I? I have 70, I don't know this angle. Cosine rule would work better. But which side do I need to start on? The x, yeah. Okay, let me zoom out a bit. Right, so using the cosine rule starting with the x, I have x squared equals r squared plus l squared minus twice or l cos 70. So x would equal root r squared, which is 15 times 10 to the 8, plus l squared, which is 59.1. 59.1 times 10 to the 8 minus twice, zoom out more, twice 15 times 10 to the 8 times 59.1 times 10 to the 8 times cos 70. Okay, type that in.
For the rule you used, shouldn't we put like the hypotenuse outside, or you can put any side?
Any side. It's flexible. It's nice like that. So you can start with any side. It doesn't have to be the longest side.
But the angle must be between two sides.
Yeah, it must be the angle, but you must use the angle between the two neighbouring sides. Well, should be a big number, right?
Math error.
Oh, has your calculator gone outside the range or something?
Yeah.
Right, do we get an answer here? Is everybody's calculator breaking down or something? Do we have an answer? Or?
You forgot to put the square for the 50.
Oh, thank you, Matar. I didn't write my square on the second fella.
Oh.
Maybe that's causing problems. Oh, that's the maths error because the answer was negative under the root.
Yeah.
So what do you get now? Yeah, go on.
Is it a wrong number?
Yeah. What's after the 7?
7.
Okay, so three significant figures be 558. And I think it's 10 to the 9 meters.
Yeah.
Yeah. Now if you want, that's 558 times 10 to the 6 kilometers. So 558 million kilometers is the answer. Yep. 66, which number? Huh? 1A. Let's have a look-see. Can I scroll down? Yep. Right, so you have y equals 3 cos bracket 2 bracket x plus pi over 6 close plus 1. Yes? Is that part okay? So let's make our table. What have we got? Start, end, min, max. 0, 2 pi, minus 1, 1. Right, what does the tree do? What does the tree change? Yeah, amplitude. What does the 2 change?
The end started at end.
Which will be now what?
Pi.
Pi. What does the pi over 6 do?
Minus. the
Minus,
six
yeah.
pi.
So that would be pi over 6 and 5 pi over 6. And what does the 1 do at the end?
Min and max.
Min and max, yeah?
The 5 pi over 6
Yeah.
How do you get 5 pi over 6?
Pi minus pi over 6. Like this?
Yep.
Okay, when we're ready now, we'll draw. Now, the graph wants me to go from minus 2 pi to 2 pi, so that's what I'm looking at here. When you're ready, we'll scroll down.
So do we have to do the table like that?
You have some other one?
The start, because like in high school, like
Yeah.
we just get the x and y
Yeah?
values, then we just plot this.
Oh, that's so middle school.
Yeah.
Oh no.
Okay.
No. I mean, you could, but how many points do you think you would need to get an accurate graph?
4 points.
Until the end, but I didn't do it that way here because I felt that
I forgot this one, right?
Oh, I don't know. I don't like it.
Okay.
I just feel, you don't think this is easier?
Okay.
If you want, yes, you could absolutely. There for the exam, they do not specify a method. So to answer your question, yes, you could do it that way. But I like this way more.
Okay.
All right. Can I go down to the graph?
Teacher, does
Yeah.
this table hold any marks?
No, there's no marks going for the table. I'm only doing this to help me make the graph. All the marks are at the graph stage. So that's why I'm saying it doesn't matter. You know. Okay. Let's see. What did I say I need to go to? 2 pi, was it?
Yeah.
2 pi on both sides. So I'll put 2 pi here and minus 2 pi here. And we'll go 1, 2, 3, 4. And minus 1, 2, 3, 4. Now, let's think about how I have to subdivide it. So look, I have pi's over 6 here, don't I? So maybe I have to be moving in pi's over 6. So let's put some key ones in here. There's minus pi. Oh, look at the disgrace of this graph. That's terrible. That's way too far to the right. I need to move that like about here. Bit better? Maybe. Okay, let's mark in some more. Right, there's 2 pi. There's, ugh, it's still terrible, isn't it? Oh, whatever. Pi, 2 pi. Okay. Minus pi over 6. I better mark that. That would be 1/6 this length. So that would be like here. And then 5 pi over 6. That would be here. just 1/6 of pi from the left. Let's do our dotted lines. And then -2. And then 4. Now we have to copy and paste. So if that's 5 pi over 6, and I have to move pi units to the right, because the difference here is pi. This is a length of pi from here to here. So the next point will be here. And then likewise, the next one would be here. And the next one would be a little bit outside. And then the next one, no, we don't need. Okay, so cos, and now I have to make the quadrants. So 1, 2, 3, 4, 5, 6. The middle would be after 3 units. 1, 2, 3. Okay. And now I don't quite have my boxes yet. I have to split each of these boxes in half. It's getting a bit messy, I know. Just to remind you, one box is this. Wait, what did I do? Did I screw something up here? No, sorry. One box is this. Minus pi over 6 to 5 pi over 6. That's one box. And then this is the next box. And this is the next one. And this is the next one. What am I missing in these boxes? I haven't done the vertical line to split it into 4 yet. So that would be like, I put in brown. Here. 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 And here. Okay, time to make the graph. Cos starts at the top, doesn't it? Goes down. And then back up. 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 And I think that matches up with my picture pretty well. Pretty well. Okay. Okay. Yeah.
Is one period enough for graphing?
Say again?
Is one period enough for graphing the trigonometric functions?
What do you mean by one period?
One period.
Oh, but see, this question actually said to go from -2 pi to 2 pi. So one period wouldn't be enough for this one. You see in question 1a, at the end it says between -2 pi and 2 pi.
But isn't the period will? The period will change after we get the period.
I'm not sure what you're asking me. What was the period for this one? It was pi.
It was pi between 5 pi over 6 and
Minus pi over 6. So that length is pi.
yeah.
And this length they want is 4 pi. So I ended up drawing 4 periods. Yeah. Yeah?
Yeah.
Anything else?
So it is like it writes here negative pi to 2 pi.
Yeah.
You must draw. Okay.
Who am I missing? Nobody? Okay, we're finished there.
Sir, test papers on Moodle, is it recorded and
You mean in like the folders with the years? Yeah, they are, yeah.
seems really straightforward.
You think that until you're sitting the exam.